We now discuss about the next form of that linear form, that is Bernoulli's equation. As we have discussed about linear differential equation like dy by dx plus p of x into y is equal to q of x. That was called linear equation. But it's not like always the problem will be in that form. Sometimes, suppose if you are seeing a format called dy by dx plus p of x into y equals to q of x, till there it will be same as linear. But into y power n is also present on the right hand side, where n is not equals to 0 and 1. Then we call this particular type as Bernoulli's equation, or it is also called as non-linear equation, because this is not the form of linearity. It is something extra other than linearity. So then how to solve this type of problem is, so we have to first, since we have learned so much about linear and it is a small correction that is to be made on the right hand side. So we will try to reduce it to linear if possible. This is what the attempt is. So how to find the solution of this is, first it should be reduced to linear, then it will be solved by linear method. So what we do is, since this y power n is obstructing the d, we will divide throughout the equation by y power n. That is what the first step. So dividing the entire equation by y power n, or multiplying the equation by y power minus n is what the attempt. So we just do that. Then we'll see like this: y power minus n into dy by dx plus p of x into y power 1 minus n is q of x. So it is not nearing to our linear, but so many corrections to be made. So what we'll do here is, instead of y power 1 minus n is there when we compare to linear differential equation. So what we'll do, we'll take it as substitution. So put y power 1 minus n as t, then differentiate on both sides. 1 minus n dy by dx into y power minus n is dt by dx. This implies y power minus n dy by dx is 1 by 1 minus n dt by dx. So we'll substitute this in the given equation. So it becomes 1 by 1 minus n dt by dx plus p of x into t equals to q of x. Right? So almost we are nearing to our linear format, but not like dy by dx. It is in the form dt by dx. No problem. We can also solve with this type of notation. So, but still it is not in a proper form. That 1 by 1 minus n is a constant that we can remove it by multiplying with 1 minus n on both sides. So once we multiply like this, we see the form called exact, that is a linear DE. See, dt by dx plus 1 minus n p of x into t equals to 1 minus n into q of x. 1 minus n is a constant, that never matters, that will not obstruct the form. So this is called linear only, but it is in t. Earlier we had in y, in x. Now it became as linear in t. So the procedure will be same. So what is the procedure? We have to find integrating factor and write the solution with respect to t. That is t into if, like that it will start. So that is what written. Solving the bilinear method, we have to substitute t as y power 1 minus n at the end, because we have to finish the solution in y only, because t came in between. It is not the main variable. Our main variable is y, what they have given. But for our convenience, we have taken the concept called t here. So you can see in the previous. See, put y power 1 minus n is t. That means we have to write it back again. So at the end, we will put back y power 1 minus n as t. So that finishes the solution. On RHS, whatever the function of y exists, that is what the hint given. So any other function of y exists other than the x, we just divide with that on both sides and then proceed. Is one of the simple observation if the problem suggests you that. See this problem? X dy by dx plus y equals to x cube into y power 6. See here almost it is nearer, but some term is obstructing. See, this y power 6 is there. So we'll divide the term with this y power 6. Also, x into dy by dx is there. X should not be there. We'll divide even by x. So dy by dx plus y by x became x square y power 6. Everything is perfect if that y power x is not there. So divide the equation by y power 6 or multiply by y power minus 6. So by doing that, see here we have got like y power minus 6 dy by dx plus 1 by x1 y power minus 5 is x square. So what we'll do is this y power minus 5 term is there, right? That we will name it as a t, like what we have discussed in the previous problem, like a procedure. Put that y power, whatever you got in the second term, as a t. Then differentiating with respect to x on both sides, minus y minus 5y power minus 6 dy by dx is dt by dx. We need only y power minus 6 dy by dx to substitute in the equation. That's why I written that, which is minus 1 by 5 dt by dx. Then put the same in the given equation. It becomes dt by dx minus 5 by x is equal to t is equal to minus 5x square. So this is in the form of linear equation in t, like linear in y, linear in x. Now this is linear in t. So once we recognize it as linear in t, so the two steps called finding the integrating factor and writing the solution. So integrating factor is e power integral p dx. So what is that? E power minus integral of 5 by x is, that is 5 into log x, that is log x power minus 5, finally x power minus 5. And writing the general solution, that is t into if is integral q into if dx plus c. So here integral of x power minus 3 we got, which is simple, x power minus 2 by minus 2. So but we got it in t, but we should not end the problem in t because that is what we have assumed for our convenience. So write back the t what we have assumed, right? That is y power minus 5, and end the solution in x and y and constant. So this finishes the problem. So like that many problems you can check. See here also, dy by dx plus x into sine 2y is x cube cos square y. So we can observe only cos square y term, that function of y term is obstructing. So divide the equation by cos square y. So we'll make the equation comfortable. See here, 1 by cos square y secant square y, and written sin 2y as 2 sin y cos y for further simplification. So when we simplify this, we got like this. Now that second term, whatever be the y term is there, put it as a t. So tan y is t. Then differentiating, we'll get secant square by dy by dx is dt by dx. That's it. Once you got this, if you substitute, it is linear in t. So once it is linear in t, we have to go with integrating factor and general solution. This finishes the problem. So like this, we can have a trial with our Bernoulli's equation when the equation is not completely in the linear form. So if any term is obstructing that, let us divide and see, and slowly with the substitution, it will come to the linear form. So these problems you can practice and check that they are applicable for Bernoulli's. It is called Bernoulli's. So all the hints are given and answers are mentioned. You can practice. You can see the problems. You'll come to know the hints by your own. When you have a good practice of the problems and when you understand the concept, it will be very easy for you, like it can be done with these methods. When you do more problems only, you'll have a good practice. And just like that, we cannot say by doing 1 or 2 steps, you'll come to know. So many problems are just mentioned, listed here. You can go with that.